Hello, everyone. Um, I'm sorry that I'm going to have to cancel class yet again today. My daughter woke up not feeling well, so we're going to do a video lecture for today, Wednesday, November 8th. So today we are going to finish homework 11, and to do that, we've got properties of logs left. I did want to mention a few topics I decided in homework 11, I decided to make extra credit. So I posted a couple of videos about transforming the log and exponential graphs. So the um, the transforming the logs and exponential graphs are going to be extra credit in ALEX, so you don't have to do those topics. They'll be optional. And there aren't like base graphs and transformations of graphs. So the graphing exponential functions topic in ALEX and the graphing logarithmic functions topic in ALEX are both going to be optional. There are videos in there to help you. But I do want to note that you will be responsible for the knowing what the basic shape of these graphs look like. So logs have a vertical asymptote and they kind of look like an exponential on its side. These guys live, the domain is 0 to infinity. Your range is negative infinity to infinity. And again, they have a vertical asymptote at x equals 0. If your base is bigger than 1, you're going to be increasing from left to right. And if your base is a fraction, you'll be decreasing from left to right. And then exponential graphs, these are what these guys look like. And again, these are logs on their side. Logs are exponentials on their side. They're just sideways. These guys have horizontal asymptotes rather than vertical asymptotes. And so they all have horizontal asymptotes at y equals 0 initially. The domain is negative infinity to infinity, and your range is 0 to infinity. If your base is bigger than 1, these guys increase from left to right. That's called exponential growth. And if your base is a fraction, we decrease from left to right, and that is called exponential decay. Okay, so again, you'll be responsible for the basic graphs, but no transformations. I'm not going to test you on those. They'll be optional for you. And then the other topic that's going to be optional here is finding the domain of a logarithmic function. And basically, there is a video to help you with this on D2L as well, but I just want to kind of mention it. It doesn't matter what your base is. If you have log base b of stuff, then you have to make sure that the stuff inside your log is strictly greater than 0, and that's because the domain of a logarithm is x is greater than 0. So you got to make sure that anything that you're taking the logarithm of has to be greater than 0. So basically what you're going to do is you're going to apply this domain rule to what you're given, and then you'll have to solve the inequality that comes out of this rule. Again, there's a video on D2L to help you with that, but finding the domain of logarithmic functions will be an optional topic in ALEX. It'll be extra credit. It'll be added into your ALEX grade at the end of the term. So you can do those for extra credit if you like. Okay, and then to finish out homework 11, we're going to do properties of logs. There's 3 topics dealing with properties of logs. So let's get into this. There's going to be 3 main properties of logs that we'll use. The product rule is when we have a product inside a logarithm. Product in math means multiplication. So we're going to use this when we have 2 things being multiplied inside a logarithm. So if I have log base b of m times n, notice I've got multiplication inside this logarithm. And in that case, what we can do is we can actually split this up into 2 logarithms. Multiplication on the inside turns into addition on the outside. So this turns into log base b of m on its own plus log base b of n on its own. Multiplication inside turns into addition outside, and they each get their own logarithm when we do that. And basically, if you're curious where these come from, because logs are exponentials, just backwards, and the value of logs are exponentials, this actually comes from the fact that when you add, or when you multiply two exponentials with the same base, you add their exponents. So this is just based on exponent rules and the fact that logs are exponentials, but backwards. Okay, so that if we have multiplication inside, it turns into addition outside. Quotient rule we're going to apply when we have a quotient inside a logarithm. And in math, quotient means division. So we're going to use this one when we have two things being divided inside a logarithm. So if we have log base b of m divided by n inside, then again, we're going to split this up into two separate logs. And the division inside turns into subtraction on the outside. So we're going to do log base b of m minus log base b of n. And I just want to mention in the addition, order isn't important. So if you're multiplying two things, you can multiply them in any order. When you're adding two things, you can add them in any order. So up here with the product rule, order was not important. But down here with the quotient rule, I do want to mention that order matters. And you got to make sure you get this right. It's going to be the top minus the bottom. So log base b of m, which is on top, minus log base b of n, which is the thing on the bottom. So order matters, you got to do top minus bottom. And then the last thing that we have is the power rule. We are going to use this when we have powers inside a logarithm. So if we have log base b of m to the p power, again, power inside a log, what happens is we can take this power and put it out front like a coefficient. So this turns into p times log base b of m. You can take your power and multiply it out front like a coefficient. And these are our main properties of logs. Multiplication inside turns into addition outside. Division inside turns into subtraction outside. Powers inside turn into coefficients outside. Okay, so let's try these. The first way that we're going to do this is expanding a logarithm. So sometimes we'll say, expand this logarithm into a sum or difference of logarithms. And here it just says write each expression as a sum or difference of logs. So basically, right now we have a single logarithm to start with, and we've got things being multiplied or divided or to powers inside the log. And we're going to use these properties to split it up into multiple logs so that everything gets its own log, and we've got addition and subtraction instead of multiplication and division. Okay, so let's start with number one, log base 8 of 13y. So we've got a property for when we have multiplication inside, we have a property for when we have division inside, and we have a property for when we have a power inside. What do we have going on inside this logarithm in number one? Well, I've got 13 times y in here. There's multiplication in here. And so if I have multiplication inside a single log, I can split this up and give each of these pieces their own logarithm. So this is going to become log base 8 of 13 plus log base 8 of y. Each of these get their own logarithm, and the base must stay the same. So we started out with log base 8, so each of these gets a log with base 8. And the multiplication inside turns into addition outside. And so we turned one logarithm with multiplication inside into a sum of logarithms. Okay. And that's our final answer. We're just looking for everything to have its own log. And you know you're done when you have one thing inside each log. You won't have multiplication, you won't have um, division, and you won't have powers. If you have addition or subtraction inside a log, you can't split that up. But we won't have to really worry about that in this class. Okay, so let's do number 2. If we have log base 5 of 125 divided by x, what operation do I have inside the logarithm? Well, I've got 125 divided by x. I've got division. So we're going to split this up into 2 logs. Division inside turns into subtraction outside. So I'm going to give each of these guys their own log. And again, the base is 5 here, so they each get a log with base 5. And I'm going to do the top 125 minus the log of the bottom, which is x. So I've got log base 5 of 125 minus log base 5 of x. And we're split up. There's no multiplication, division, or powers inside a log, so we are done. Except that there's actually one more thing that we can do in this problem that we couldn't do in the last one. We have all numbers here. Log base 5 of 125. We can actually evaluate this. Remember that log base 5 of 125 says my base, 5. To what power gives me 125? This is actually a nice power. You can play with your calculator to see, but 5 to the third power gives us 125. So log base 5 of 125 is just 3. And so this is the same as 3 minus log base 5 of x. Notice in the last one, this log base 8 of 13 was also just numbers, but this says 8 to what power gives me 13? And the answer is not a nice one, because 8 to the first power is 8, which is too small, and 8 to the second power is 64, which is too big. So we weren't able to write this one as a whole number, so you would just leave it. But if they turn into a nice whole number, you're going to want to do that. I think if in ALEKS, if you put log base 5 of 125, I don't think it's going to count it wrong, but it's going to throw an unsimplified message, and it's going to say you have the right answer, but it needs to be simplified, and it's going to give you another chance to simplify it before it counts it wrong, if that makes any sense. So if it says your answer is right, but it's not in simplest form, make sure that you've turned any of these guys into whole numbers. Okay, if you can. All right, let's do number 3. ln of the 7th root of x. Okay, I want to turn this into a sum or difference of logs if I can. So I've got a log for product. I've got a log from a, sorry, I've got a property of logs for multiplication. I've got a property for division, and I've got a property for exponents. What do we got going on inside this log? Well, it's not multiplication. It's not division. It doesn't look like a power, but it's a root. And roots can be written as powers. So let's rewrite this square, the 7th root of x inside here as a power. So the 7th root of x is x to the 1/7 power. Remember that roots come from fractional exponents. The number on the bottom gives you your index. So that's where that 7 on the bottom came from. And the exponent on x inside is 1, which is where this 1 on top came from. So x, the 7th root of x is x to the 1/7. So now we can see we have a power inside this log. And so the power rule says we can take this exponent and throw it out front as a coefficient. And when we do that, this is going to look like 1/7 times the natural log of x. And that is all we can do here. I've got x by itself inside the log with no multiplication, division, or powers in there. That's how you know you're done. All right, let's keep rocking. Log of x to the 7th times y all over z. Okay, well, we've got multiplication right up here, right, between the x to the 7th and the y. I've got division here between the x to the 7th and y and the z, and I've got a power on x. So I'm going to have to apply all of these. The order that I want you to apply these in is the quotient rule first, then the product rule, and I want you to save the power rule for last. These are the order that I want you to apply these in to expand a log. So if you've got multiplication and division and powers inside a log, to expand it out, you're going to do quotient, then product, then power. So we're going to start with our quotient rule, which is this division here. So to separate this with division, I'm going to do the log. And again, if your brain wants a base, when it's not written, this is understood to be a 10. You can write the 10 or not, whatever your brain likes. We're going to have log of the top minus the log of the bottom. So top minus bottom, and now we've separated that division. We've broken that up. But we're not quite done because we also have multiplication in here. So now I'm going to apply the product rule to that multiplication here. And so I'm going to turn this multiplication inside to addition outside. And again, they're each going to get their own log with base 10. I'm not going to write it that this time because my brain prefers it simpler. But if your brain wants the 10, write the 10. All right, so these guys are each going to get their own base of 10. So I'm going to have log base 10 of x to the 7th plus log base 10 of y. That's splitting this guy up. And then I still have this minus log base 10 of z hanging out over here. So I now don't have any multiplication or division inside any logs. We've taken care of that. But I do have an exponent. And so I'm going to apply the power rule. I'm going to take this exponent and put it out front as a coefficient, and this becomes 7 times the log base 10 of x plus log base 10 of y minus log base 10, sorry, sometimes I write it, sometimes I don't, of z. There's an understood 10 there. If you like to write it, go ahead and write it. And if not, then don't. And that's our final answer because I have a single thing in each log and no multiplication, division, or powers left. Okay, let's do another one. Log base 2 of y to the 4th over x to the 3rd times the square root of z. I've got a lot going on here. I've got multiplication down here. I've got division up here, and I've got powers on everything. So don't panic. The first thing that we're going to do is split the quotient. We're going to do the division first. So to do that, I'm going to do log base 2 of the top, which is y to the 4th, minus log base 2 of the bottom, which is x to the 3rd, times the square root of z. I'm going to want to write that square root as a power, so I'm going to go ahead and do that from the beginning so I don't have to do it later. The square root of z is z to the 1/2 power, because again, a square root is an understood index of 2, and so the square root of z is z to the 1/2 power. All right, so I've split this up top minus bottom, and I don't have any division left. But I do have multiplication right here, so we're going to split that up using the product rule. So I'm going to keep my log base 2 of y to the 4th, and then I'm going to subtract this, but I'm going to split this, right? Multiplication on the inside becomes addition on the outside. So I'm going to have log base 2 of x to the 3rd plus log base 2 of z to the 1/2. They each get their own base of 2. Now we have to be careful here because we subtracted this entire log, And so when we split this up, we need to make sure that we subtract the whole thing, which means we need to subtract all of this that we split. And so this negative is going to have to be distributed to each one of these that came out of this. So let's go ahead and do that. So I'm going to have log base 2 of y to the fourth minus log base 2 of x to the third minus log base 2 of z to the 1/2. Just distributed that negative. And then the last thing, we don't have any multiplication and division left, so we've taken care of all of those. Last thing we have left is the power rule. So I've got exponents on all of these. So I'm going to take each of my exponents and throw them out front. And I'm going to have 4 times log base 2 of y minus 3 times log base 2 of x minus 1/2 times log base 2 of z. And now we are done. Everything has its own log, and there's no multiplication or division or powers left in a logarithm. And then something that I want to point out here that's going to help us in just a minute. Here in number 5, notice that anything that came from the top has a positive logarithm, right? The y to the fourth came from the top. So that y is right here. Its logarithm is positive. And notice that both x and z came from the bottom down here. The log of x is negative. The log of z is also negative. That's a thing. Anything that came from the top should have a positive logarithm. Anything that came from the bottom has a negative logarithm. So make sure that that happens so that you distribute all your negatives properly. Top is positive, bottom is negative. And that's the same thing that happened in number 4. The x came from the top, its log is positive. The y came from the top, its log is positive. And the z came from the bottom, so its log is negative. That's going to help us in just a minute. Okay. Last thing we want to do here is number 6. What if I have the ln of the 5th root of x y to the 4th over z squared? What if I have a root on all of this stuff? Okay, well, I want you to start thinking about roots as powers. So this 5th root is actually a power on everything in here. So I'm going to rewrite this as the ln of x times y to the 4th over z squared. And all of this is going to be to what power? This was all inside a 5th root. A 5th root is a 1/5 power. And so now I've turned this root into an exponent. And now I can apply this exponent to everything inside of here. Because I only have multiplication and division in here, I can just distribute this exponent to everything in there. Again, you can only do this with multiplication and division. You cannot do this with addition and subtraction. So when I apply that, if I have powers, 2 powers, I'm multiplying them. So x to the 1/5 power is x to the 1/5 power times y to the 4th to the 1/5 power is y to the 4 over 1 times 1 over 5, which becomes 4 over 5. I multiply those exponents. 4 times 1/5 is 4/5. And again, to help you see that, write 4 is 4 over 1. And then on the bottom, I've got z squared to the 1/5 power. So again, I'm going to multiply my exponents. 2 is 2 over 1 times 1 over 5. You'll multiply across, and I'm going to get z to the 2/5 power. Okay. So now we can go ahead and start splitting this up. Now that I've kind of taken care of that root and applied it as an exponent to everything, now I've just got multiplication, division, and powers in here, and I know what to do with that. We're going to start with quotient rule. I'm going to have the ln at the top minus the ln at the bottom. And then I'm going to have to split this multiplication, so they're each going to get their own logarithm. So I'm going to have ln of 1/5 plus the ln of y to the 4/5 minus ln of z to the 2/5. And I don't have to distribute any negatives. X and y both came from the numerator. They both have a positive logarithm. And z came from the bottom. It has a negative logarithm. And then the last thing I have to do here is my exponents. I'm going to take each of these and throw them out front. And overall, I'm going to get 1/5 times the ln of x plus 4/5 times the ln of y minus 2/5 times the ln of z. And everything has its own logarithm. And there we have it. Okay, so that is using these properties to expand logarithms. If you start with multiplication or division or exponents inside, you're going to use these properties to split them all up into separate logarithms. All right, what if we wanted to go the other way? What if instead of starting out with one logarithm with like multiplication, division, and exponents inside, and turning that into addition and subtraction of logs, what if I start with a sum and difference of a bunch of logs, and I want to condense them into only one log? So like in number 5, I've got 2 logs. I've got log base b of x and a log base b of y. I've got 2 logs, and I want to write this so that I only have one log in the end. Okay, so really what we're doing is going backwards here. We're going to start on the right side up here. We're going to start with our sum or difference, and we're going to work our way backwards to multiplication and division inside a single logarithm. And since we're going backwards, we're also going to reverse what we did before. So our order here, this was for expanding logs, right? If we had a 1 log and we were expanding it into multiple, this is the order that we're going to do. But if we are condensing, sorry, I'll try to fit this in. If we are condensing, then the order that I want you to do this in is backwards. So since the power rule is the last thing that we did to expand, it's actually going to be the first thing that we do to put everything back together. And then after we apply the power rule, what I want you to do is apply the product and the quotient rules at the same time. And I'm going to talk you through that. I promise it's going to make sense. But I don't necessarily want you to do the product rule, then the quotient rule, because that's going to get confusing sometimes. So first we're going to do the power rules, and we're going to take our coefficients out front, and we're going to throw them up into the exponent. And then we're going to apply the product and quotient rules to turn addition outside into multiplication inside, and subtraction outside into division inside. All right, so let's do this. Okay. All right, so let's start with number 1 here. I've got 5 times log base b of x plus 6 times log base b of y. First thing that we're going to do is the power rule, but backwards. So we're going to take our coefficients, and we're going to put them up as exponents inside each of these logs. So the 5 is on the log base b of x, so this is going to turn into log base b of x to the 5th power inside that log. Then I'm going to do that same thing with that 6. I'm going to take that 6 and I'm going to put it into the exponent on y inside that log. And so now that I have all my powers up here and I've got the logs all by themselves, now I'm going to take addition outside, and addition outside turns into multiplication inside. So now I'm going to write a single logarithm, and I'm going to put these guys together. Addition outside turns into multiplication inside. So I'm just going to multiply these guys inside a single log. And we have condensed this into one log with multiplication, division, and powers inside. Okay, let's do this again. Number 2. First thing that we're going to do is coefficients up into powers. Do I have any coefficients on my logs? Yep, I've got a 2 right here. So I'm going to take this 2 and I'm going to put it up into the exponent here. And so this is going to turn into the natural log of 3x plus 7 to the second power minus the ln of x. Okay, we've done all of the turned the coefficients into powers, and now we can condense this into a single log. So now I'm just going to write ln. I'm going to have one log, and I'm going to turn subtraction outside into division inside. And remember, it's top minus bottom. The thing with the positive log goes on top, so that 3x plus 7 squared is going to go on top. And the thing with the negative log goes on the bottom, so that x goes on the bottom. Top minus bottom. And so now I've condensed this into a single logarithm with multiplication, division, and powers inside. Awesome. Let's keep rocking. We're getting more things now, like we're continuing to add more logarithms, but that's okay. We've got this. And so number 7, first thing that we're going to do is the coefficients. We're going to make them exponents. So we're going to do that on each one here. Put those up into the exponents. And so we're going to have log base 2 of x to the 7th minus log base 2 of y to the 3rd plus log base 2 of z to the 1/2 power. So we've done, we've put all of our coefficients up into exponents. And now what I want you to do is apply the quotient and product rules at the same time to put this into a single log. Now, I don't want this to be super overwhelming. What we're going to do is use our knowledge of positive logs means the thing inside came from the top. If the log is negative, that means the thing inside came from the bottom, right? So basically what I want to do is put our toys away. So I'm going to make a division bar here. This is kind of like our shelves, and we're going to put our toys away. X to the 7th, does it go on the top shelf or the bottom shelf? Well, it has a positive log, and so that means it's going to go on the top, because anything with a positive log means it had to come from the top. So that goes on the top shelf. Y to the 3rd, does that go on the top shelf or the bottom shelf? Well, its log is negative, which means it came from the bottom shelf. So I'm going to put my toys away, and y to the 3rd goes on the bottom shelf. And then this z to the 1/2 power, its log is positive, which means that it goes on the top shelf. So I'm going to put it away on the top shelf. And now everything is back where it goes inside a single log, and we are done. So you can leave it this way, or if your brain likes roots better, you can turn that z to the 1/2 into the square root of z if you like. I'm fine with either one of these, whatever your brain likes best. Does that make sense? Okay, so hopefully that all makes sense. You're going to put your coefficients up into the exponent, and then you're going to put your toys away. So let's try number 4. I want you to pause this video for a second and try to work through this one on your own. Put the coefficients up into the exponent and then put your toys away. And then when you're ready, hit play. All right, hopefully you've had a chance to work this one. Let's see how you did. So I'm going to take these coefficients and throw them up into exponents. And when we do that, I'm going to get the ln of x to the second power minus the ln of y to the fourth power plus the ln of z to the eighth power minus the ln of w to the fifth power. So we've taken each of those coefficients and put them up into the exponents. And now we can write this as a single logarithm, and we're going to put our toys away. So these are all ln's, so I'm going to have a single natural logarithm. I'm going to make my shelf, and I'm going to put my toys away. X squared goes on the top shelf because its log is positive. Y to the fourth goes on the bottom shelf because its log is negative. Z to the eighth goes on the top shelf because its log is positive, and W to the fifth goes on the bottom shelf because its log is negative.
That's cool.
Oh, thanks.
Like the tablet you're going on, I just came up to ask. I want more toast.
Okay, I'll help you in a second. Sorry, my daughter came to ask for something. So I will we'll finish this up and then I'll take care of her. So we moved all of our coefficients up into the exponent, and then we put our toys away. And there we have a single log with multiplication, division, and powers inside. Okay, and then the last thing that we're going to do is apply these properties to evaluate a scarier looking expression without a calculator. So we're just going to start with our properties, and we're going to condense these into a single log so that we can see what we have. So let's start with number 1. We're going to apply our properties. Where do we start? Well, with condensing, we start by putting our coefficients up into the exponent. So I'm going to take this 2 out front and make it an exponent up here. So I'm going to have the ln of e to the fifth minus the ln of e to the sixth to the second power. Now I've got powers, 2 powers. How do I deal with that? You multiply them when you have powers, 2 powers. So this turns into the ln of e to the fifth minus the ln of e to the 12th. And then from here, it's a bit of a choose your own adventure. Right now, we can simplify this. The reason for that is, what's the base of these logarithms? ln is log base e. So these both have e as the base. So this first one says my base, e to what power gives me e to the fifth? And the answer is 5. And then the second one says my base, e to what power gives me e to the 12th? And the answer is 12. So we can simplify this from here. 5 minus 12 is -7. So you can solve it that way. If your brain doesn't see that right now, and it wanted to go straight to, oh, I've got a subtraction, I'm subtracting 2 logs, I can combine those. You could have also, here, let me switch colors here so it's obvious that this is an alternative. You can also combine this into a single logarithm and put your toys away. So you'll have e to the fifth over e to the 12th, right? E to the fifth will go on the top shelf because its log is positive. E to the 12th will go on the bottom because its log is negative. And in that case, we're going to have to simplify here. when we are dividing two things with the same exponent, you subtract them. So this is the ln of e to the 5 minus 12, and 5 minus 12 is -7. And so now this is base e, and this says e to what power gives me e to the -7th, and the answer is -7. So notice you'll get that same answer either way. It just depends on if your brain sees that you can simplify it right here, it makes your life a little easier. But if your brain wants to combine those into a single log, you'll come here, and that's totally fine. Okay, so let's try these last couple. Number 2, log base 14 of 7 plus log base 14 of 2. I don't have any coefficients, so I don't have anything to do there. I'm going to combine these into a single log. So I'm going to have log base 14 of addition on the outside turns into multiplication on the inside. So I'm going to have 7 times 2 inside this log. And so this means log base 14 of 14. Well, what's the value of this one? This is asking my base 14 to what power equals 14? And the answer is 1. So log base 14 of 7 plus log base 14 of 2 is just 1. And then the last one here, number 3, log base 3 of 36 minus 2 log base 3 of 2. We're going to start by condensing, so we're going to take this coefficient and put it in the exponent. And so we're going to have log base 3 of 36 minus log base 3 of 2 to the second power. Well, 2 to the second power is just 4, so this is going to be log base 3 of 36 minus log base 3 of 4. And now I can condense this into a single logarithm. I'm going to put my toys away. 36 goes on top because it has a positive log. 4 goes on the bottom shelf because it has a negative log. And so this means log base 3 of 9, because 36 divided by 4 is 9. Log base 3 of 9. What's the value of this one? Well, this says my base, 3, to what power gives me 9? And the answer is 2. Okay, I'll be right down, honey. Thank you. Okay, and so now you can apply your properties of logs to what you're given, and then use our knowledge of what logs mean to write your answers. All right, and that completes the material for homework 11. Homework 11 is due on Sunday. That is November 12th at midnight. And then we are going to start homework 12 on Friday and continue with 12 Monday and Wednesday of next week. And then test 4 is next Friday. It covers homeworks 10, 11, and 12, and the study guide has been posted on Alex. So as always, please let me know if you have any questions. I hope you have a great day, and I'll see you on Friday.